All right. And so today we're going to talk about identifying your data science bowl problem, and really think about how the most challenging part of executing in data science for social good is defining that problem statement with all the stakeholders. And that's what we'll talk about today, what our process is at DataKind for doing that. So I'll try to monitor the chat as we go, so please feel free to share any questions in there. I'll first go over why listen to us, who we are at DataKind, and then talk about the 6 components of a successful data science for good project, which will bring us into the bulk of today's session on building your problem statement and how to really identify that problem that you want to use data science for, and each of the different pieces involved in that, which go from impact maps through technical feasibility, human-centered design, product sustainability, data, and ethics. And we'll see if anyone has any questions and share where to find more information. So I'll start with why listening to us. So first, who am I? I'm Rachel. I am a senior manager of community programs at DataKind, and my background is in corporate data science consulting and international development data work at IPA. And I've been at DataKind now for 3 years, where I focus on really enabling our community of social impact organization professionals using data science in the service of humanity to grow their organization's ability to use data. And DataKind is just all about harnessing the power of data science and AI in the service of humanity. We work with volunteers and partner organizations as a global nonprofit. And so we help social organizations identify what those data science and AI challenges and opportunities are that they're facing. And then we recruit and manage teams of experts to build solutions for them. And finally, we stick around to ensure the solutions are used and that the impact, the goal is really achieved. And we're there for the long haul with our partners. We work around the globe. We recently had a data dive in Nairobi this summer, and we've got over 20 and done a lot over the last decade that we've been in existence. So one example is a project that starts with a sobering fact. So 36% of the global population lacks access to a toilet, which contributes to health and environmental problems. And this issue is particularly evident in Haiti, where there were nearly 14,000 cases of cholera in 2017. Our partner organization, Soil, is a nonprofit that works on dignified sanitation in Haiti, and they've provided 1,000 households with container-based sanitation toilets and safely transform all collected waste into agricultural-grade compost. But Soil had 2 challenges. First, managing the costs and logistics of transportation, and second, a lack of easy-to-use optimization tools. And so our team was able to help them solve this capacitated vehicle problem by creating a software solution that leverages OpenStreetMap and Google OR tools that produce an output of HTML maps and text instructions that can be used without a cell or data access. And at last assessment, using these solutions, Soil was able to cut down overall trips by 13%, which was huge resource savings. Next, our first attempt at a one-for-many solution was with Vision Zero, which is a global movement centered on the idea that no pedestrian or bicyclist death by motor vehicle is accepted. And so, armed with the question of how do we reduce traffic deaths, DataKind brought together a consortium of stakeholders in 3 partner cities. And the team was able to use primarily open data to build a machine learning model of all the features of crash prediction. And we also wanted to understand how dangerous or safe an intersection is and if it would need intervention. So we had to understand how many vehicles pass through it. And we built crash models that allow the cities to simulate the effects of different engineering and policy interventions. And with over 100 features in the models, we found that the features of most importance included the traffic volume estimate, signal count, so number of signal boxes, a raised median, number of intersecting streets, and the count of bus lines on the street. And with a focus on designing across multiple localities, the team was able to take the work forward more broadly. And so problems like these are difficult or impossible to solve because of incomplete contradictory, and changing requirements that are often difficult to recognize. They often include ill-defined end state. For example, when will we have solved poverty, right? So that's why we call them wicked problems. As a quick illustration, Netflix does not solve wicked problems. Netflix uses data and fine-tunes recommendations ultimately to keep you coming back for more and thus increase profits. And so social implications only matter if they hurt the brand enough to decrease profits. And then on the flip side, we'll go like reducing the time to detection of malaria outbreaks definitely is a wicked problem. We see success only when malaria rates decrease and our solution does no harm. And a solution must preserve equity and agency. What works for one hospital or one country might not work for another. And a true global solution would need to utilize hundreds of data sets, features, and outcomes. And this brings us to our goal today. We want to address the question, how do we use data science to create solutions that tackle wicked problems, work within big, messy systems, and serve the good of the many? So we've been working on answering this question for over a decade at DataKind. Unfortunately, finding problems can not only be harder than finding solutions, it's also way more important. This is what we really need to focus on, especially if you want to be a piece of moving the needle on large scale change. So over the years at DataKind, we've had experienced many instances of problems that were difficult to define. It's really difficult to measure bringing people out of poverty or increasing social justice and equity. So defining that root problem that causes massive social injustices that would actually change the world if it was addressed, it's nearly impossible. And that's why we prioritize scoping at DataKind. So the answer to how we might use data science to serve the good of the many is all about building a solution that's scalable by defining your problem well. It's all about that work done up front. And so this brings us to the 6 components of a successful data science for good project. Please, if you have a question or something that you'd like to share, please feel free to just go off mute. You can raise your hand, and I'm happy to keep this very informal since we have a small group, and we can all chat. So please feel free to just chat in the you can type in the chat or come off mute if you'd like to contribute to the session as we go. So don't be shy. Okay. And so at DataKind, we've identified these 6 key components for success in a data science for good project. First, data scientists. This might be you. You might be a data scientist. At DataKind, this is one of the things that we provide. We have pro bono data scientists. And so a lot of people in the room are data scientists, and this is where you fit in. Or you might be identifying data science talent in a number of alternative ways, like through a company's corporate social responsibility program or by hiring data staff. And even if you are a data scientist, you might want to work with other data scientists with complementary data skills, which is a common model for us at DataKind with our partners. And next, for social impact organizations, it's essential to find donors who are willing to invest in data science with you. In government or for good private organization, this could mean getting buy-in or getting budget from leaders to ensure there's sufficient funding for your data project. Next, social actors and subject matter experts are key to identifying the right problems to address and to co-designing data science solutions. The answer to the question, are the problems we are addressing the ones that matter? Without them, there's no way that we can answer that question. There's no way data scientists would be able to build solutions that address those root challenges based on research that last a long time and that are applicable in the field based on the experience of social actors and improve our world. So if you're a data scientist coming up with a project idea without any subject matter experts or without social actors working on the ground in the space that your idea is, it's really important to get a deeper understanding of those needs and partner with folks to know what problem you're actually solving for and get to know the people your data work will impact. And so this leaves us with what we're going to focus on today, problem statements and data. So we'll go into the bulk of our agenda on building your problem statement. DataKind has a very simple, high-level project concept statement template that we use for all our projects. And it forms the cornerstone of all DataKind proposals, briefs, and strategic decisions. And we're excited to be sharing it openly with you today. So we'll spend most of our time today returning to this statement as we gradually fill it in. But be careful, we're not actually going to start at the top. We're going to start at the end with the impact that you're trying to achieve. So this is how we ensure we're addressing wicked problems and truly making an impact. And this brings us to our first consideration in scoping a data for good problem. Impact maps. You may want to ask, what data should I collect since you're talking about a data science project? Or I've got this data, what should I do next? But if we want to address wicked problems and truly serve the good of the many, we need to start with identifying the right problem to address. And this is how we identify that so what impact that we're going to make in our problem statement. So we want to hear about what success looks like for the social actors on the ground. We use these brainstorming questions to identify the impact that the social actors want to make. What's your vision? What change do you want to see in the world? What does the world look like when the team has fulfilled its mission? What's most important to your organization or community? In summary, we ask, what is your so what? To answer those questions will ultimately put us at the end of our problem statement to demonstrate that impact that we want to make. And this might be the easiest part because we know what we're trying to achieve, or it might really require focusing on partnerships with subject matter experts to identify that impact and goal. But I'll start with an example that we'll go back to throughout this webinar. You might be trying to address poverty in a developing country through financial inclusion programs for rural farmers. And therefore, the impact you're interested in making is that subsistence farmers break out of the cycle of poverty. So that's your big impact statement that goes in the first blank. Maybe it's Ugandan subsistence farmers break out of the cycle of poverty. Or you might be interested in ensuring that humanitarian aid gets to those who need it the most. And another example of how that impact statement goes at the bottom of the problem statement. So next, we want to think about what behavior change we want to make in order to move the needle on our desired impact. So in order to determine the behavior change you want to happen so that you can make your desired impact, you need to understand how each activity you do maps to your mission. This is what these brainstorming questions get at. So ask the social actors, what's the process for achieving the vision? How do you map your activities to your mission? The answer to this question for most social organizations is their theory of change or logic model. And at DataKind, what we call an impact map is how the data science project fits into the logic model or theory of change in your organization and thus maps to the impact made. Maybe you're not familiar with a logic model or theory of change. Don't worry, it's pretty straightforward. It just maps your activities to your impact and shares what happens each step along the way. There's lots of great resources online, and feel free to look them up, do a search on the internet and find more resources. So at DataKind, we're huge advocates for focusing on that theory of change or logic model to identify the behavior change you want to make so that you can move the needle on your impact. And as you scan your theory of change, you'll likely see several options of things that can go here in this spot. So think creatively and come up with several options. What change do you want to make that will ultimately end up completing your vision? So here are some brainstorming questions to consider as you scan your theory of change. Look for areas in your impact map that someone could pick apart and ask, does this really imply that? So find bottlenecks, find areas for improvement, challenges, pain points, and then document everything that might be standing in your way as a change you want to make in your problem statement. So let's go back to our examples. Say you're trying to address poverty in Uganda through financial inclusion. If your desired impact is that Ugandan subsistence farmers break out of the cycle of poverty, potential behavior changes include a few different options. We could go in a few different directions based on what you've identified as those areas for improvement in your theory of change. So at this point, it's great to have several options. Maybe it would be great if micro-lending programs operations became more efficient. Maybe services could be better targeted to the farmers experiencing the most extreme poverty. Or maybe financial service providers need to be able to get to the most remote villages quickly to serve more people. So all of these potential behavior changes map to Ugandan subsistence farmers breaking out of the cycle of poverty, and they're all measurable. So bringing it back to our problem statement, we see that services can be targeted to the poorest farmers experiencing the most extreme poverty so that Ugandan subsistence farmers break out of the cycle of poverty. Now we'll look at our other examples with the desired impact of ensuring humanitarian aid gets to those who need it the most. You may notice that your theory of change has more elements than just one so that, and your bottleneck or challenge is further down the line. So here's an example of what that might look like. Many humanitarian organizations know that they can effectively get aid to those who need it the most if they're able to provide complementary services or serve different areas geographically rather than duplicating efforts. They also found that the more effective allocation of resources across organizations is required to provide those complementary services. And in order to more effectively allocate resources, organizations need to share data that can be used to make decisions. Therefore, in order to effectively allocate resources after sharing and using data to make decisions, they want to make the behavior change of sharing access across organizations to all relevant information for crisis response. And that's what goes into the problem statement as the behavior change. So bringing it back to our problem statement, we see that humanitarian organizations have access to all the relevant information for a crisis response so that humanitarian aid can be delivered to those who need it the most. So with some changes mapped out, it's time to move to the top and decide what analysis we want to do. So technical feasibility can be the hardest leap to make, and that's where we're going now. So we start with some brainstorming questions to help determine the analysis to do for the project statement. If you're comfortable with data science, ask yourself what projects might create the desired behavior change. And if not, ask yourself who might be the users of a solution. How might they use it? If a solution was adopted by everyone, what would it solve? These questions help identify if you're on the right track, and they should map back to your problem statement. If you're new to data science, or even if you're not, a useful place to start is simply asking yourself if what you want to understand is understanding the past, improving the present, or predicting the future. So consider what you could gain from a better understanding of the past, or what might be useful to automate in real time or know in real time, or what do you want to be able to predict before it happens? And as you brainstorm technically feasible solutions, there are three big buckets that projects fall into. First, counting and reporting is an essential first step for all organizations on a data science journey. And this can be data science if you're using unique new data sources or video or audio images. Next, testing and modeling is popular for predicting the future or identifying the impact of a program, for example, with a randomized control trial. So once you've got all those statistics and the ethics down, you can also consider asking yourself, what can be automated through machine learning or AI? What could a computer do that would really free up time for humans to be humans? So here are some examples of machine learning at DataKind and how we've used it to help you come up with ideas for what you might do. Find out how many people are likely to be in need of housing support in the next month through predictive modeling. Plan a route for a driver to visit the most hospitals as fast as possible by automating laborious tasks. Decide what food pantry needs donations the most by optimizing resource allocation. And discover what material a farmer's roof is made out of, and therefore their likely poverty level, through analyzing satellite images. So these are all ideas for analysis you might want to do, filling in that first line of your problem statement. You should come up with as many ideas as you can because data access might narrow down your options, or with ethical examination, you might find there are unintended consequences of project success, and that might make you want to pivot your idea. So we'll narrow down to selecting one project shortly when we talk about data and ethics. Remember the 6 components from the beginning? While strategizing on possible data science solutions, it's important to research existing solutions to ensure we're not reinventing the wheel. This is an essential time to work closely with subject matter experts and social actors to ensure the data science project you're suggesting is the right fit for addressing the challenges your end users are facing. Don't assume that since you're in the data science part, the data scientists can fully take over. These elements are very important. So let's go back to our examples, starting with our financial inclusion organization that wants to help Ugandan farmers break out of poverty. We came up with 3 sample possible behavior changes that the social actors and subject matter experts agree will lead to the desired impact. So let's look at some sample data science projects for each of them, all of which are references to projects that DataKind has done. First, Grameen Foundation came to DataKind wanting to measure whether bikes increase efficiency enough to justify a new program using bikes to give support for financial inclusion programs to farmers. And our project helped Grameen decide to cut the program because it wasn't providing as much value to the farmers as Grameen had hoped it would. But we count this as a success because they were able to make a data-based decision and use their resources more effectively. Beyond just a simple credit score model, which is generally only a predictor of past performance, how do we actually predict future loan repayment? So this is work we did with Microcred in Senegal and Simpa Networks in India, building alternative credit scoring techniques to allow these organizations to reach previously overlooked populations. Sometimes after you've identified that behavior change and impact, your data source actually helps you decide what project you want to complete. So since GiveDirectly knew they had access to satellite imagery data, they wanted to look at roofs to identify the poorest households in Uganda. Of course, this only works in the project statement because it maps to their desired impact and behavior change. So those are 3 different examples of real projects that focus on breaking farmers out of poverty. Now we'll go back to the humanitarian aid organizations that work towards getting aid to those who need it the most and want to increase access to all relevant information for a crisis response across the sector. So DataKind has actually been working with 3 organizations towards this aim on a project that kicked off a few years ago. We're focusing on work with Save the Children right now, but we've also worked with CARE and Oxfam to identify and consolidate relevant data into one cross-organization accessible interface so that humanitarian organizations have access to relevant information for a crisis response so that humanitarian aid gets to those who need it the most. So technical feasibility is all about the key deliverables and outputs and confirming that it's possible to achieve them with a defined data science methodology and the data science capacity on your team and the existing data. So this brings us to human-centered design. We have a few principles of human-centered design that we apply to all our scoping efforts, but I'm going to also take this as an opportunity to pause and just see if anyone has any questions so far. I'm not seeing anything in the chat, but please feel free to come off mute or type in the chat if you have any questions so far. All right, I'll keep going, but please feel free to interrupt me if you come up with something. First, Communication and people come first. We have a no jargon standard. There's a lot of people who know a lot about APIs and a lot about SDGs. And a problem we run into is when we let people assume other people understand the alphabet soup. So we really explain everything. And most importantly, as I already mentioned when we talked about the 6 components of a data science for good project, we design with, not for. If you don't have the end user engaged in the design, you'll end up with a solution that likely just sits on a shelf and is never used. Or even worse, you might have a solution that's implemented in a way that does harm. And so this is why it's key to incorporate social actors and the communities impacted by the work into your data science project scoping process. Your users should help you write your problem statement. Incorporating good design principles in your data science for good project is what is going to take us beyond the initial excitement of a cool, flashy project to the real lasting change, moving the needle on wicked problems and making the world a better place. So I would argue that 90% of data science for social good work is problem wrangling in partnership with on-the-ground social actors and subject matter experts. So in summary, good data science follows good human-centered design. Writing your problem statement is about doing your research before you come up with your ideas about what you will do, and carefully designing before you start working. So you might be wondering, why do you need to think about product sustainability during the initial stages of the project process when you scope? So this is a key consideration because you don't want to propose something that's not sustainability. So the sustainability plan should be mapped out from the start. We can't be satisfied with a solution that only works once all the time, as true value really comes from long-term replication and scale that enables systems change. So the project may be unique to your organization, but a good, impactful data science for good project will move towards systems change. Your project should have reusability, applicability, and learnings that can be reapplied elsewhere. If nothing else, at least learnings that can be reapplied elsewhere, right? So here are some brainstorming questions to consider as you think about product sustainability. What are the environmental conditions of the final solution? How fast would the solution be outdated? What will it take to sustain the product? Is your organization prepared to support the product after the project is complete? Is your organization ready to accept and integrate the results, even if they reflect potentially uncomfortable deficiencies or changes in how you should operate? If the answer is no to either of these last 2 questions, reconsider the project you're thinking about doing. We just talked about local context last week alongside human-centered design, but I would be remiss to not mention it again as we discuss product sustainability, because this is where your solution will break down if you haven't built with the users and within the local context. The product will fail to sustain if you don't incorporate the communities impacted during scoping. So now that we've incorporated impact, technical feasibility, human-centered design, and product sustainability into our problem statements, it's time to finally start talking about data. Since we never finished our problem statement, see, we still have one blank left to fill in. So how do we find data? Now, you might be surprised to see us getting to data last, but we believe it's important to start with the problem, not the data, when scoping a data science for good project to ensure you're doing work that actually makes an impact. First, find out what data your organization has. Think of departments you might not traditionally go to, as well as those you would expect to house helpful data. So take stock of what data you have available internally and think creatively about how the data you have might be useful to address a problem identified through your problem statement and impact map. Make sure you've explored all internal data source options for data that you might be able to pair with open data to address your challenge. Next, once you've exhausted internal data sources, it's time to consider publicly available data, frequently referred to as open data, bringing us to number 2 on our list, open data sources. To start summarizing some examples of open data sources, we'll use the context of this project to help humanitarian aid organizations that work towards getting aid to those who need it the most. There are tons of open source relevant data available from multinational organizations, both at the countrywide macro level and the individual household or person micro level. The UN, IMF, World Bank, regional banks or organizations all have tons of useful open data on employment and jobs, or even data on things like peacekeeping efforts that might be useful if you have a recovery-focused idea. So this is one of the sources we brought together for our humanitarian data project to get aid to those who need it the most. Additionally, most governments have employment and labor data that can be useful for understanding the jobs of tomorrow. You can find government data on their statistics department's websites, a few of which are given above, but all of which are easy to find online. So try typing open data and the country name into a Google search. And if that doesn't work, you simply need to know what you call your statistics department or ministry. Central banks are another good source of data about economics. We also brought in some country government level data for this example project. Finally, our largest data sources in this case was the Humanitarian Data Exchange. So disaster response, data on aid workers, and lots of humanitarian response to COVID data can be found on the Humanitarian Data Exchange. This is a great place to look if your project is related to humanitarian work. So data.humdata.org. So DataKind merged these and other open data sources and found the keys to bring them together as part of this project. So DataKind is helping Save the Children, CARE, and Oxfam identify and consolidate relevant data into one cross-organization accessible interface using open source humanitarian response data from multiple jurisdictions so that humanitarian organizations have access to relevant information for a crisis response so that ultimately humanitarian aid can be delivered to those who need it the most. So with that, once you've exhausted internal and open data sources, it's time to start thinking up creatively about overlooked data and unique ways you can collect data. We'll start with the exciting new overlooked data sources, sensors, drones, the Internet of Things. Generative AI is a great way to develop data. And additionally, you're probably familiar with a survey. So this is important in many cases, but there's also different types of survey methodologies that we can talk about for overlooked data sources like crowdsourcing and social surveying. Worth mentioning, though, that social surveying does not enable you to guarantee a sample of respondents that reflects a random sample of the population of interest. So it's not good for building statistical models that rely on representation. Still, crowdsourcing and social surveying are great places to start with a limited budget for project design and in socially distant times online through social media platforms and email. Just be mindful to gather your data and check for representation of all types of people from your population of interest. Now for a unique one, metadata and other digital exhaust. Metadata is the data about the data. It's been around for a long time, but it's often overlooked because it's not as flashy as new sources, but it can be extremely valuable. So consider what metadata you might have internally and alongside public data sets, and think carefully about how you might use it. And digital exhaust is the trail someone leaves as they explore the internet. If your users are engaging with you digitally, look into digital exhaust as a potential data source to better understand your users by seeing how they explore and interact with you online. Of course, only use this data if you've received consent from the users to do so. Web scraping is pretty easy with APIs, which are just an application interface that makes programming even easier. It converts the internet into data, but make sure to check the legality of your project before you start, because there are restrictions on what can and can't be scraped from the web. So be careful to educate yourself on your data sources, rules, and regulations. And as part of the humanitarian data project I just shared about, one of our teams incorporated some open Facebook data to overlay movement during COVID. One website that's pretty simple to scrape data from is actually Google. If you're interested in Google search results, you can decompose any ranking into open data. Now let's get back to one of our examples, the financial inclusion organizations that want to help farmers break out of poverty. We've identified a few open data source options for microcred in Senegal and Simpa networks in India, in addition to the internal private banking customer data on behavior, which includes things like historic performance, previous loans, and products. DataKind combined this information with public government data giving household financial norms, as well as sector performance data from financial multinational organizations. And all these data combined contributed to the predictive models built. Satellite imagery data is available through many open data sources that can be helpful for all kinds of projects. Open Aerial Map is one source that includes data that covers much of the globe. We also used open satellite data for the humanitarian response project mentioned earlier. For an example of using open satellite imagery data, we have the project with GiveDirectly that we already mentioned. We want to identify the poorest households in Uganda using roof materials identified in satellite images so that services can be targeted to the poorest farmers experiencing the most extreme poverty, so that Ugandan subsistence farmers break out of the cycle of poverty. So now that we have all of these great data sources available, how should you evaluate your source and decide what to actually use? This brings us back to DataKind's scoping process. Before deciding to do a project, we always conduct an inventory and a review of the state and quality of the proposed data sets to be used and verify enough promising data is available to bring your ideas to life. In what we call data audits, we check that the project description is clear about what data sets will be used and that the data is ready to go for analysis. So consider the following questions as you decide whether to use the data you found. How does the data set, what does the data set represent? How was it collected? How credible is the source? How much is there? Is it well defined? What are the most likely biases that could be in the data? What data are you missing, and how might that influence project outcomes? If these are starting to sound to you more like ethics questions than data source questions, you're right. It's impossible to separate selecting your data source from ensuring ethics are incorporated into your data science project, which is why this brings us to ethics. Our last few minutes are certainly far from enough time to fully understand data ethics, so be aware this is only meant to be an introduction that provides you with some guiding principles to think about, not a comprehensive data ethics training. So I encourage you to explore this topic more as you consider your data science project, and we'll provide a resource for doing that next. The bottom line is that you should not suggest automating anything if you haven't thought carefully about ethics. We're going to talk about how this means and how ethics, privacy, and risk should be designed from the start. So we know that artificial intelligence and data science work requires proper training and consideration to be ethical. But what do we do about it? It sounds simple, but it's the truth. A big part of ethics and data science is just to talk it out, deliberate what the possible ethical implications could be of the project, and make a decision based on those conversations. Ensure there's space to both discuss and veto as needed projects that impose undue risks to data subjects. Ethics is a process, not a destination. We should approach ethics with thoughtfulness as we affirmatively create space to pause and collaboratively ask hard questions, not just assuming we have one checklist to ethics success. We account for vulnerable stakeholders and consider who or what might be missing from our training data. So systematically ask whether an algorithm directly or indirectly sorts and acts upon people according to social and political power. So who lives downstream from your data set? Are you unintentionally using historical proxies for race, class, or gender? Will your algorithm exacerbate unjust social or political dynamics, or will it help resolve them? We ask who gains and who loses. So we've all started to see questions pop up around just because can you do it? Should you? And it's imperative for us designing with vulnerable communities and populations to be proactive and prepared to think about how our solutions could be applied, especially when a machine is contributing to decision-making. Use transparent, interpretable algorithms that can tell you how they work instead of a model that can't be explained. A lot of people might be quick to jump to the most exciting, newest models out there, but that means increased risk if it's not interpretable. Be mindful of and discuss the values that are and are not embedded by your algorithm, depending on what models you want to use. But even if we've made all of these considerations and co-designed with communities, we need to account for the trade-offs in technology. Even with good intentions, biased data, unexplainable algorithms, or the inability to change algorithms can still creep in. So as we acknowledge the trade-offs, here are some questions to consider. This list and the short presentation are not exhaustive, it's just an intro. But with that, what does success look like? Who will it affect? Who has the power to change it? What risks are we taking? What's the worst that can happen both if we fail and if we succeed? Consider whether just because it can be done, should it? Are there other ways to get to the results you're looking for? Where you really need to think carefully about AI ethics is when you try your best to do good, but you still do harm. These more subtle considerations are often more dangerous because of how hard they are to spot. But you need to identify potential machine or human errors that could have severe human consequences. So trade-offs between legitimate human values are inevitable in technologies that sort and act upon human lives. So it's essential to ask yourself if changes in power structures are transparent, just, and reversible. What is the worst that could go wrong, and what trade-offs are we willing to make? Be careful what you optimize for, because your algorithm just won't optimize for anything else. So with all that in mind, define your risks and dependencies early on with a mitigation plan, listing assumptions and constraints. It's essential to be an organization that recognizes the limitations, pitfalls, and ethical nuances that could arise throughout the project. Understand how work can be misused and that private data must be safeguarded. While you may be encouraged by what we can produce, you should be equally concerned about the misuse of sensitive data, statistical bias, and the nuance required to communicate the results to non-technical audiences. So that brings us to our last section here, where to find more information. Please, if you have any questions, share them in the chat, because we're about to go into the questions section, or come off mute and interrupt me. As data science and AI become increasingly accessible and used across the social sector, we're wondering at DataKind, how can we ensure that ethical and high-quality work is done to make a positive impact? What have we learned about using data science and AI for social good over the last decade? And how can we make that information accessible to everyone and usable by all in the information age? And this caused us to build the DataKind playbook so that all our lessons learned from our failures and successes can be codified for use on future projects. So the playbook is a globally accessible living knowledge base that enables the reader to implement every element of a Data for Good project following DataKind standards and processes. I'll put the link in the chat. It's playbook.datakind.org. But in particular, you can find many resources on ethics in the playbook, So this quick overview that I just provided won't be all that you're working with. You can find a lot more specifics on how to incorporate ethics into project design in the playbook. We spent 2 years developing the playbook to capture 10 years of lessons learned. So please feel free to explore and share your feedback. All right, and that brings us to the questions portion of today's session. Who has questions that you'd like answered? Please feel free to come off mute or put them in the chat today. So I want to make sure people can get to other sessions. So I'll just close by saying thanks so much. This concludes the materials we've prepared. And if you're interested in working and getting involved with DataKind, please feel free to subscribe to our newsletter is the best way to do that. datakind.org/subscribe, I believe, is the best way to stay involved with everything going on at DataKind. And you can also just reach out to me if you have any questions for me.